Alhamdulillah wa salatu wa salam ala Rasulullah Muhammad bin Abdullah wa ala alihi wa sahbihi wa mawala wa ba'd. Evening, my listeners, my viewers, and my subscribers. Inshallah, today at Source Academic Online class, we are going to be journeying through electrolysis. So, what do we mean by electrolysis? Let's break this topic down. Electrolysis in chemistry happens to be, we are going to do two things here. We will study what is electrolysis and we'll pick one law of electrolysis. So we have like two laws of electrolysis, the first law and the second law. I'm going to talk on the what? The first law because of the time constraint. Inshallah, let's see what is even electrolysis. All together? So when we are saying electrolysis in chemistry means the art of breaking down a compound. The art of what? The art of breaking down a compound. The art, let me write it on the board. Electrolysis is what? Is the art of what? Of breaking down a what? A compound. So, or let's write it in full. A compound. The art of breaking down a compound, either in molten or in solution form through the use of what? Of electricity or electric current, anyhow you pronounce that. So that is electrolysis. Electrolysis simply means the art of breaking down a compound. Compound, like in chemistry, when we say compound, like, let me cite one example, like sodium hydroxide. So the art of breaking down sodium hydroxide, the art of breaking it down using what? Using electricity. So if this dissociates by giving us sodium and hydroxide ion, this is sodium ion, hydroxide ion. The art of what? Breaking this down. This is a compound. Break it down. But what? The art of using electricity to break this compound down to this and this, to sodium ion and hydroxide ion, is what we call what? Electrolysis. Through the what? Through the impact of what? Electricity. That means it is simple. When you are defining electrolysis, the art of breaking down a compound like sodium hydroxide, like sodium chloride, any compound, as far as chemistry is concerned, the art of breaking them down into their ionization form, using what? Electricity. Are we together? In nutshell, you can practicalize this by what? By, if you have a beaker, if this is a beaker and it contains what? Water. I won't dip too much on this. And it contains water, and you decide to what? You pour this inside, you inject this inside this water. Are we together? And you pass what there? You pass two electrodes there. This one is electrode, this is electrode, and you connect wire to it. When you connect wire to it like this, and you connect a cell to it. When I say cell, I mean battery. So when you insert this, already sodium hydroxide is inside it. What do we want to do? We want to break it down. Is that not it? We want to what? We want to break it down. The art of using two electrodes. This, let me signify, this is positive, this is negative. We call this anode. We call this cathode. Are we together? So the two of them is what we call electrode. So electrode is the combination of both what? The anode and the cathode. When we now insert them inside water containing the compound we want to break, and we pass wire to this both electrode, and we connect battery to it, we connect cell to it, so it will dissociate this, it will break this down. So the process of breaking this down is what we know as what? Electrolysis. Inshallah, in the next video we are going to talk more, but this is the practical what? Explanation on how you can understand electrolysis. This is the practical form of it. Is that noted? So let's recap. Electrolysis is the process in chemistry that involves the art of breaking a compound down through the use of what? Electricity to break them down. Altogether, to dissociate them. to make them undergo ionization, meaning they should be one. They shouldn't be bind together again. That is electrolysis. I hope you've taken that. Now the next thing I'm going to be saying here, because of the time frame, I know that mostly in this anode, what happened there? Oxidation occurs there. What do we mean by oxidation? As far as this electrode is concerned, oxidation occurred here. What do we mean by oxidation? Mean production of what? Oxygen take place here. Then at this what? At this cathode, which is the negative what? Electrode. What occurs there? Reduction occurs there. Reduction in chemistry means production of what? Hydrogen. Hydrogen gas is produced here. Oxygen gas is what? Produced here. So when oxygen gas is produced here, we call it what? Oxidation occur. When hydrogen gas produces here, we call it what? Reduction occur. So they can ask you, what are the two reactions that occur at cathode, at anode and at cathode? Oxidation occur at anode, reduction occur at cathode, forming oxygen gas, forming what? Hydrogen gas. But both are what? Electrode. Are we together? That means, in nutshell, as far as this video is concerned, I've explained what is electrode. Now, electrode is just the anode and the what? The cathode. Are those what? Are those conductors? These are conductors, which is known as the what? Anode and what? Cathode. Positive charge and what? Negative charge, as far as electrolysis is concerned. Which this anode and cathode are made up of carbon graphite or metal. So these two ions that you're seeing, these two metal, they are produced from carbon what? Carbon graphite or metal. Are we? And the purpose of them is that when you insert them inside here, it serves as one catalyst that speed up what? How this thing is being dissociated. Are we? That means for electrolysis to occur, there must be presence of what? Presence of two electrodes, which is anode and cathode. And their main function is that you can't put wire inside water directly. You need to pass the wire through them, connect the battery, and what you want, the compound you want it to what? Break, it start breaking. Are we together? Now let's take note of that. The second thing I need to tell you here, so I don't want the video to be more bulky. The next thing I want us to look into is that they can ask you. We have explained what is electrolysis. We've explained what is what? Electrode. Are we together? They can ask you, state first law of what? Electrolysis. First law of electrolysis, simply state that. Are we together? First law. And that law is what we call Faraday law. First law of what? Of electrolysis. They do ask very well. First law of what? Electrolysis. Known as what? Faraday's law of what? Faraday first law of electrolysis. This law is very simple. Just understand what you are cramming. Even if you want to cram and understand what you are cramming. First law of electrolysis say that. Are we together? This stated that the mass of the compound you subjected inside that water, the mass of the substance you subjected inside that water is directly proportional. Are we together? Is directly proportional to the quantity of the what? Of the electricity that you pass into that water. That is just it. The mass of the what? Substance deposited inside that water. That means that dissolved inside that water is directly proportional to the what? Quantity of electric current or electricity passed into that what? Into that process of electrolysis. That is it. Let me recap. This first law of electrolysis states that the mass of the what? Substance deposited inside during electrolysis is directly proportional to the what? To the what? Quantity of the electric current passed during the electrolysis. Are we together? Now, in chemistry, what they want, when you blow that theoretical aspect, you must be able to tell them the mathematical expression. It can be mathematically expressed as M, which M, it is denoted as the what? Mass. Is directly, I started breaking the what? The first law, I've started breaking it down using the mathematical expression. Because this is the main thing they want you to. Even if you know the above, you must be able to still say this thing. Are we together? Mass, they prefer this more than the theoretical aspect that I blew just now. Mass, which is representing M, is directly proportional to the quantity. Quantity, we use Q to denote quantity of electricity. This is serving as the mass of the substance deposited Q is serving as the what? Quantity of electricity passing during that electrolysis. Now this is the directly proportional sign. This is the proportional sign. So you find a means to erase this by under variation as far as mass is concerned. M equals, you change this to equals K. Are we together? Wherever you're saying this, you replace it with equals K. Then you put this Q there back. Is that noted? Please do not forget to like, share, and also what? Subscribe there. Comment. Now this M serves as what? Mass. Where I'm seeing K, we don't need K. So whenever I'm seeing K, I will be representing, K means constant proportionality sign. Whenever I'm seeing K, I'll be replacing it with Z. With what? Z. As far as this topic is concerned. And what do we call Z? What is the name of Z? We call it electrochemical series. Electrochemical equivalent. Electrochemical what? Equivalent. So if they ask you what's Z, what is the name of Z? So wherever I'm seeing here, I'll be replacing it with Z. And the name of Z is electrochemical what? Equivalent. Now Q serves as quantity of what? Electricity. M serves as what? Mass. So I can therefore replace this as M equals to what? ZQ. This is first law of Faraday. As far as electrolysis is concerned, this is the law relating what? This is the first law. So we can use this formula to solve some questions. Are we together? And you can decide in a question if you are given mass, you are given electrochemical equivalent, but you are not given Q. In case of Q, you are given current and time. So in some case, are we together? Or maybe you are asked to find current. So note that Q can be the same thing as IT. This Q means quantity of electricity. Is that? I here means current. T here means what? Time. When we times current with time, it gives us what? Q, quantity of electricity. So I can replace this back by saying M equals to what? Z I what? IT. This is another formula. This formula and this formula are the same thing. Are we together? But in case you are given a question, you are not seeing Q there. You are seeing I and T there. And you are asked to find M. Are we together? You make use of this formula. In case you only see M and Z, you are asked to find Q. You don't need to go to this. Are we together? So that is that. Now let me break it down before we start picking calculation. Know that where M, you tell them the name of M. M represents what? Mass. M equals mass. And what is the SI unit for mass as far as this topic is concerned? Kilogram. Then Z means what? Electrochemical series. It has no SI unit. But what follow? What do I means what? Current. Then what is the SI unit for current? Ampere. Then what follow? Time means what? T means what? Time. Then what is the SI unit for time? Seconds. Please let's take note of that. What again? Q here means what? Quantity of what? Quantity of what? Of electricity. And what is the SI unit for quantity of electricity? That is coulombs. We make use of what? C, coulombs. Are we together? So now, inshallah, let's pick just one calculation as far as this is concerned. I'll clean this up now and we'll pick calculation under this. Welcome back. So let's try and take one example to back the first law of what? Faraday electrolysis. So please do not forget to share to the needies. So, and let's see this question. Calculate the quantity of what? There's of here. There's of here. Let me clean this. Sorry for that. Quantity of what? Of electricity with a electrochemical equivalent of 3.0 times 10 raised to the power what? 4 that will liberate 30 grams of metal. Now, how do we solve this? Know that this question, how do I relate it to first law of electrolysis? Whenever you read a question, as I read this question now, whenever you see a question, you come across a question like this, and the question involves this thing, electrochemical what? Equivalent. That should notify you that they are discussing a question under what? First law of what? Electrolysis. So they won't tell you that this question belongs to first law of electrolysis. But the main thing to note there, for you to know that this question, what formula will I need to input here, is that just check that question. It must have electrochemical what equivalent. That will tell you that that will tell you that they are talking about what first law of electrolysis. And what is the first law? It states that M equals to ZQ. I have stated the theoretical part. This is it. It equals to the, or what? M equals to what? Z I and what? T. The same thing. But the main bone of contention here is that between this and this, which one I'm going to go for? You can take your time, pause that, and pick the correct one to take for this, for which you use to solve this. Know that I know you guys are right. It should be this one. Why is it this one? Firstly, let's check. Let's write the data given. Data what? Given. Now let's read the question again. Calculate the quantity of electricity. Quantity of electricity is denoted as what? Q. So that is Q. Q is unknown. That is what we have to calculate. Now, with the electrochemical equivalent of what? Of these. What is that? What is the symbol for electrochemical equivalent? Z. I told you earlier, which would be what? 3.0 times 10 raised to the power 4. Then what follow? That will liberate 30 grams. I told you earlier, they don't need to mention mass. What will tell you that they are talking about mass is the SI unit that is there, which is gram. That will not quickly notify you that this 30 belongs to what? Mass. It will now be M, which will be 30 what? 30 grams. Then what join Q, Z and M together? Is it this one or this one? This one. Are we together? The next thing you need to do, you will now compute everything. What would that be? M equals to what? Z what? ZQ. What do I make the subject of the formula here? Since it is Q that we are looking for, divide both sides. What is blocking Q? Z. Divide it by Z. Divide this by Z. This settles this. We are left with what? Q equals to M over what? Z. Is that not it? Then what follows? Let's substitute in our parameters. What is M? The value for M is what? 30. Divide by, what is Z? The value for Z is what? 3.0 times what? Times 10 raised to the power what? Minus what? Times 10 raised to the power 4. Sorry. This is what I'm having. Then let's try and break this more. Let's try and break it down more. Are we together? Then what follow? Let me clean this since we've noted that. So that means our M now, our Q rather, will be mass over Z. Is that not it? So now what is the next thing I'll do? I'll try and break this. How do we break this? You can do this without using a calculator. What this denominator is, it is what form? Standard form. This one, whole number. You can decide to make these two to be in standard form. This one is having 10 raised to the power 4. I can induce another 10 raised to the power something here. How would I do that? Let's pick this. 30, Q equals 30 over what? Over 3.0. What are we having here? Let me break it like this. Times 10 raised to the power what? 4 times 10 raised to the power 0. Did you agree with me? 10 raised to the power 0 in maths under indices, it equals to what? Anything raised to the power 0 is 1. 1 times 30 is 30. You can see it's still the same thing as this. This one, 30 times 10 raised to the power 0 is still the same thing as this, 30. But the reason I'm saying 10 raised to the power 0, I want to make this one, it is whole number before. I want to make it in standard form, the same way this one is. That is how I'm using it. Bringing this in doesn't change the what? Doesn't change it from this one. It's just to cancel something, to simplify. What do I do? 30 divided by 3. What would that be? 30 divided by 3. It will be what? Q will now be 30 divided by 3 will give us what? Let me break it like this. 30 over what? 3 times we pick 1. 10 we pick what? 1. What is the power? What is the power that this is carrying? Is 0. Divide the under math signifies what? Minus. Then what are we having here? 4. Are we together? 10 here, I'll pick 10. Law of indices. When we are having the same base, you pick, this is base, we pick 1. Then we what? Since we are having divide, we minus the what? The 2 power is 0, 4. Is 0 minus 4. Is that noted? So the next thing I'll do is that 3.0. The next thing I'll do, Q will now be 30 divided by 3. 3.0 is still the same thing as 30. Are we together? So 30 divided by what? Sorry. 30 divided by 3. What would that be? 10. How many 3 are there in 30? 10. Are we together? So what is the next thing? Times, then 10. Is 0 minus 4? What would that be? When nothing minus something, we get what? Something, which is minus 4. Are we? So this is the final what? Final answer. Are we? And know that what will be the SI unit for the quantity of electricity? What do I say earlier? Coulombs. Coulombs. So I'll put what there? I'll put C here. Are we? So this is the final what? Final answer to this. Are we together? You can still break it this further, but this is the final answer here. If you want to break this further, you can do like this. Q equals to 10 times this. You can remove this minus by introducing 1 over 10 raised to the power 4. I've erased this minus. When you are erasing minus in law of indices, you use 1 to signify that. What would that be? Q will now be 10 times 1, 10 over, what do we have here? 10. Are we together? Then this is over 1, this is 4. Is that not it? What do we have again? Law of indices. When we are having the same what? The same base, you pick what? 1, which is 10. What do I have as a power here? 1. When you have 10 like this, that has no power, that is 1. This is 1. Then divide will change to what? Minus. Minus. Then what are we having here? 4. What would that be? 10. 1 minus 4 will give us what? Will give us what? Minus 3. If I'm not mistaken, then coulombs. That is the final answer. Is it like this or this? If you can't find this, if it is objective question, you will find it. Now, if you can't find this, you will find this anyhow it is. And you can still break this down by, if you want to still remove this minus, 1 over 10 raised to power 3C. This is another final answer. So that is that. I still remember my humble self, AKOREDEOLUWAYINKAHASSAN, our Source Academic online class. Do not forget to like, share, and subscribe. These are how we solve the question under what? First law of what? Faraday. Let me give you one assignment to back it up. So here, let me change this to 60 gram. Then let's change this to 4. Then let's change this to what? 5. Try and calculate the quantity of what? Electricity present there. Barakallahu fikum.